Degree of freedom or DOF is related to the motion possibilities of rigid bodies. Kinematic definition for degree of freedom of any system or its components would be the number of independent variables or coordinates required to ascertain the position of the system or its components. Let's understand degree of freedom in more simpler terms. Let's take the example of a car. A car is moving along a straight road. Now, how to determine if it has traveled from one point to another? It's simply done by calculating the distance it has traveled. So, distance here is the independent variable. Since only one independent variable is defining the motion of the car, hence the car has degree of freedom 1. Now let's take another example. Here is a windmill. The rotation that the windmill makes is dependent upon the independent variable theta or angular displacement. Since there is only one independent variable, the degree of freedom of windmill will also be 1. Now let's take the example of an aeroplane. The plane can move up and down in the air or in the Cartesian coordinate system. Up and down the y-axis, that is plus y and minus y. Forward and backward, that means towards plus x and minus x axis, and also towards us and away from us or plus z and minus z axis. It can also rotate about all the three axes. Let's say theta is the angular rotation about x-axis, phi is the angular rotation about y-axis, and gamma is the angular rotation about z-axis. So altogether, there are 3 translation motion and 3 linear motion about the x, y and z axis respectively. So the 3 translation motion has 3 independent variable x, y and z, whereas the 3 rotational motion has 3 independent variables theta, phi and gamma. Now, the degree of freedom of a robot typically refers to the number of movable joints of a robot. A robot with 3 movable joints will have 3 axes and 3 degree of freedom. A 4-axis robot will have 4 movable joints and 4 axes, and so on. While it is not absolutely the case, most pick-and-place devices and robots have several capabilities like moving in a straight line, moving object from one place to another, and many more. But the most amazing movement would be of roll, pitch and yaw. Let's take the same example of an aeroplane to understand roll, pitch and yaw. An aircraft in flight is free to rotate in 3 dimensions, in which yaw means plane's nose left or right about an axis is running up and down. Pitch means plane's nose is running up or down about an axis, running from wing to wing. And roll means plane's rotation about an axis, running from nose to tail. Similar is the case with robots. The x-axis is considered to be the machine's forward direction. Rotation about the x-axis is called roll. Rotation about the y-axis in case of robot is called pitch. And the rotation about the z-axis is called yaw. Now let's understand some of the common pick and place robots. First is a one-axis robot. It can pick up an object and move it along a straight line. The two-axis robot can pick up an object, lift it, move it horizontally and vertically, and set it down or present it on XY plane without changing the object's orientation. The three-axis robot can pick up an object, lift it, move it horizontally and vertically, and set it down or present it anywhere in the X, Y, Z space within reach of the robot, and it also doesn't changes the object's orientation. The four-axis robot can pick up an object, lift it, move it horizontally, and can set it down or present it in the XYZ space. But in case of four-axis robot, a change of object's orientation can be seen along one axis, so it would be an example of yaw. The five-axis robot can pick up an object, lift it, move it horizontally, and set it down in an XYZ space, while changing the object's orientation along two axes. That means this is an example of yaw and pitch. A six-axis robot can pick up an object, lift it, move it horizontally, and set it down in an XYZ space, while changing the object's orientation along three axes. So this kind of six-axis pick and place robot has all the three movements: yaw, pitch, and roll. The seven-axis has all the movements capability of a six-axis robot, along with the ability to physically move the robot from one place to another in a linear direction. It is performed typically in a horizontal motion along a rail. All the examples that you have understood are of simple pick and place kind of robots and devices. In order to understand how complex robotic configuration works, we need to dig deep into 6 degrees of freedom robots. This we will discuss in the next lecture.